Good morning, everybody. Amazing timing, just like promised. So today I would like to talk to you about your job, which is being a software engineer, and what great software engineers do. The first thing that they do is they sharpen the saw. So what does that mean? Well, there's an old fable about a wise old man wandering in the forest, and he saw a couple of guys pushing a saw back and forth, trying to cut down a tree. And they weren't making much progress. So he said to them, "So why don't you sharpen your saw?" And they said, "We don't have time to sharpen our saw. We have to cut down the tree." And it's the concept that you have to get better at what you do, like take some time to go to a Java conference, for example, and that will get you able to get your job done faster rather than not taking any time out to learn at all. The second attribute of great software engineers is that they share responsibility with the entire team to deliver real value to customers. And the third is that they see the shadow of the future. That is, they work to make the world a better place. So that's what I'm going to talk about this morning. Let's start out with the idea of sharpen the saw. So I want to talk about the power of being challenged. This is, do you ever remember any time in your life when you were totally engaged in something? All distractions disappeared, time evaporated, you had no idea the time was passing. Have you ever felt that way? Yeah, okay. So that has a name, and that is called flow. And the person who named that flow was Mihai Csikszentmihalyi from what? Hungary. Okay, got it. From Hungary. And he, however, is in Chicago right now. And yes? And he started the whole concept of positive psychology. Until he started writing, all the psychologists in the world were looking for what was wrong with you. And he started talking about what is right with people and what makes people engaged and happy and have the best experiences in their lives. This is a picture from Csikszentmihalyi, and it talks about the idea of flow. So if you take a look here, there's a flow channel. And in this flow channel, you have skills and challenges. And when you have a low skill, then you need a small challenge to get in the state of flow. And as your skills improve, you need a higher challenge or you get bored. And as time goes on, and you are very skilled, you also need a very high challenge. But if you get this strong challenge before you're ready, then you slip into anxiety and can't perform. So it's this channel of flow that we move up as we get more and more skillful. In his book, he says the best moments in people's lives. Is this working? Occur when a person's body or mind is stretched to its limits in a voluntary effort to accomplish something that's both difficult and worthwhile. And when you were in the state of flow, that's what you were trying to do, accomplish something that was both difficult and worth doing. And it's getting into that state of flow when you do software engineering that creates expertise and brings you up the flow channel. So if we take a look at where expertise comes from, it takes something like 10 years or 10,000 hours of deliberate practice to become an expert in just about anything. This comes from the work of Anders Ericsson, and he's from Stockholm. See, I got that one right. And he now lives in Florida. And what he says is, in order to become an expertise, you start by identifying a skill that really needs improvement. And you devise or you learn from a teacher or a coach some exercises to practice, and you do that again and again. And when you fail, you hear about it. Somebody comments on, your coach comments on how you are doing. And you keep doing it again and again and again as you get better and better. And perhaps 3 hours a day, you're constantly practicing. So if you think about it, those people who are doing open source or open source software at night, one of the things they're doing is practicing what they do in the daytime. So this is true for musicians. It's true for athletes. It's true for doctors, even. Doctors who do diagnosis and follow up to see if they are correct get better and better. Doctors who do diagnosis and never know if they were correct don't get any better at diagnosing. And it's also true for software engineers. So that's the pattern of expertise. To summarize, what you need in order to become real experts is some sort of coach. And you need a challenge. Something that's a little bit beyond what you can do. And you need feedback, okay? Otherwise, you're not going to get any better. And you need steady progress towards getting things done. So one of the most important things that software engineers do is they do this. And they do it a lot until over years they become really good. The next thing that great software engineers do is that they share responsibility in delivering real value to customers. So I would like to propose that just doing what somebody tells you to do isn't good enough. Making sure that what you do is giving customers real value is a fundamental part of software engineering. So I want to talk about two different kinds of development organizations. The first development organization is a delivery organization. We deliver software. And the second development organization is an engineering organization. So question is, which one are you in? Are you in a delivery organization or are you in an engineering organization? If you're in a delivery organization, then what you do is measured on cost and schedule and scope. Not did you deliver value, but did you do what somebody promised that you were going to do? If you're in an engineering organization, then being able to deliver a completed, valuable piece of work is what it's all about. Engineers solve problems. They take problems, figure out how to solve them, figure out how to make things work. So who's responsible for delivering value at your job? Is it you? Or is it somebody else? In delivery organizations, maybe it's the business. You know, I'm in IT, the business figures out what value is. It's not my problem. Or maybe it's the product owner. We have an agile team. We don't worry about what we're supposed to do. I was reading about Eric Ries, who went to a company called Grocket. And at this company, the owner was figuring out how to create a website so that people could study for tests, college entrance test. And he asked the development team, how do you know you're developing the right thing? And they said, oh, that's not our problem. That's the founder's problem. He figures that out. We just do what he says. I think that's the wrong answer. Of course, the engineers are responsible for figuring out what is necessary and what is important and what should be done. And in fact, when they changed their whole habit and started saying, every time we deploy something, we're going to test and see if the website gets more traffic, see if people use it more, see if people like it, they started finally to turn the company around and become profitable. So it's not we do what somebody tells us, it's we do what customers really want. Maybe it's the contracting party. Somebody is paying us to do this set of requirements, but they're paying you for a reason. Do you know that reason? Are you making sure that that reason is accomplished? Or the outsourcing company. So what happens in a delivery organization is people point fingers at everybody else. It's not me, I'm not responsible for delivering value. It's that guy, or it's that guy, or it's that guy. And guess what happens? No value, little value, big mistakes. If you look at an engineering organization, and if that's what you're part of, the answer is completely different. Then all of us, are responsible for delivering value. We share responsibility. Okay? It's about being autonomous, yes, and cooperating with other autonomous teams to make sure that we are delivering the value that customers really want. So when you think about that, let's talk about a delivery organization that Tom and I went to 3 months ago. And I won't tell you their names because this is a very interesting organization. They had a very big, very successful product. They were making a lot of money, maybe too much. Maybe they weren't paying a lot of attention. They had a very difficult approval process because somebody, I don't know, in the senior management said, how do we know we're spending our money correctly? So it took a very long time for any idea to get approved. It went through a very strenuous approval process, and everything was focused on cost reduction. And the delivery teams had almost nothing to say about what went on during the approval process. All they knew was eventually, after a good long time, something popped out of the process and it was approved. The competency managers or functional managers or line managers had two responsibilities. They had to have a very high percentage of their people assigned to projects all the time. So they were looking for a very high utilization percent. Maybe 90% or 95% of your people's time should be assigned to one of those approved projects. And secondly, each competency manager had to estimate how many hours any project was going to take in their particular function. So if you were QA, for example, the QA manager estimated, that is going to take maybe 700 or 800 hours of QA time, and then after that, the competency manager was responsible for those hours. And those were those metrics. Now, what happened is that there was no line of sight at all from me developing software to the customer's need. It was just, here's a list of stuff to do in your functional area. So what happened? Well, the results were an awful large amount of cost being lost, huge inefficiencies. Why? First of all, the workers were assigned to multiple projects. After all, we want to keep everybody busy. And they spent more time juggling the projects than they spent actually working on them. And the teams, because, excuse me, because many of the specialists were waiting for team members, the team sat around, using up hours and assigning hours, but not getting work done because they didn't have the people that they needed. In addition, there was a huge pressure to meet each cross-functional estimate. So what happened is, if you were done with development hours, then you couldn't spend any more time on the project. If you were done with other hours, you couldn't spend any more time on the project. And you will not be surprised to learn that all of the defects cascaded down to the final testing, which took forever. But of course, the QA people didn't know what to do about that because they had limited hours too. So we had a whole large amount of extra hours in QA and still really buggy software going into production. Does that sound familiar? Would never happen in your company, right? But I did software development. I was a process control engineer. I designed systems to control big, large roll good processes at my company, 3M. And I did a lot of software development without having requirements or stories or, all those different things, that long lists of functions and features. Let me show you when I got a process control system assignment with team members, 5 or 6 other folks. We were given by our boss the charter to put a process control system on, say the new extension that's going into Oklahoma City. And what did the requirements for that project look like? It was going to take us a year. So how many pages of requirements does it take to keep you busy for a year? Well, first of all, we knew that the process itself, which was being designed by the engineers upstairs, so we would just go up and talk to them, had to make good products. So our control system had to make sure it controlled whatever equipment they were designing in such a way that the product it was making was good. It should contain the latest technology because it's going to be around for 20 or 30 years, so make sure it has the latest technology. And by the way, it has to be on time. There's no option. My boss probably would have gotten fired if anything was ever not on time, because being on time was the most fundamental way to save money and to have low cost. So we were always on time. The operators in the plant had to find this system convenient to use. We were told that, in a manufacturing plant, operators make product. And that's what they do. And if your computer system comes in and gets in their way of making product, you know what's going to happen? They will defeat your system. And if they defeat your systems, because it isn't working for them, and it's your problem. So you better figure out what it means for an operator to have a system they can use. And the plant engineer is going to maintain the system. But once it's there, now the plant engineer is a very wise, smart engineer, but of course he has all kinds of equipment to maintain, and maybe there's 2 or 3 plant engineers, but we knew that we had to have a very simple system to understand. So for example, in this case, although I could program in any language you wanted, I used BASIC. Imagine that. Because I figured the plant engineers could understand that. And everything else, besides these requirements, was our problem. We designed. We didn't have somebody else tell us how to design a process control system. That was our job. Now, if you're a software engineer, your job is to take requirements like this and solve the problem, not have somebody solve it for you. If you get pages and pages of requirements, all kinds of detailed stories, guess what? Somebody else has designed the solution. You are not designing it. So think, how do you get to the spot where you are involved in the design of the system? And I'm sure Tom Gilb here is going to tell you more about this. Hey, Tom? So what we're trying to look at is not this, okay? Not somebody going to the market, bringing back a whole stack of information and requirements and giving it to a team, but we want to connect the development team directly with customers. That doesn't mean there isn't a leader. That doesn't mean there isn't somebody who understands what the product should be, but their job is to make sure that the engineering team understands the problem that they need to solve. In fact, really brilliant systems come from matching the mental models of those who are developing a system and those who are using the system. Develop a brilliant system, then the idea is to make sure that your mental model is locked into the mental model of the people who are going to use your system. That's why we had to understand the plant engineer and we had to understand the operator in the plant, because they were going to use our system and we needed to spend some time really understanding how they thought and how they worked before we finished designing our system, because that's where brilliant systems come from. So I want to give you an example of this. It's an example not too far away. Okay, I'm going to talk about how Spotify develops products. Spotify, I don't know, you have Spotify here in Poland yet? Aha, there you go. So Spotify is, of course, a company in Stockholm. Right now they have about 1,200 people, of whom maybe 900 or so are software engineers. And let's say they have a new idea for their product, some new feature that they want to put on. How does that get to the development teams? Well, the first thing is that the management team takes a look at it by assigning somebody that really understands tech, somebody that understands design, somebody that understands the product part. A trio of fairly senior people who are going to get together and think about that new idea and come up with, say, a storyboard, not pages of requirements, but a storyboard. Here is how that thing might look, some sketches. And they try several things till they get to something that feels good. And they don't try to design the whole thing. They just try to design a first pass, a minimum viable product. And they run it by the management group, and the management group says yes, or they say, no, I don't think so. And after that, maybe they say never. But every so often, they'll say, and when they say yes, it goes to this concept of build it. So now they were. Is it? No, yes? Yes, okay. It seems like it needs to be up further here, something like that. Okay, I'll try that. So then the next thing they do is they build it. Now, what does build it mean? It doesn't mean get the whole thing ready. Try is, and internally give those things to test those inside. We're not talking to customers yet, but run it by, at that point, by the tech and the lead and the design lead get a squad. A squad is a team of people, maybe 7 or 8 people, that work together to own this new feature, this new piece of the product. And they do some experiments, and the experiments are done again and again until finally they think they have a good minimum viable product. And then they run it by the management team. And the management team says yes, or they say no. And if no, maybe it goes here or it goes back there. But eventually they probably say, okay, let's build that. The next thing they do, again, same team, same squad is here, same leaders that started out. They then release it to a very small percentage of users, maybe 1 or 2%. And they run A/B tests, lots of A/B tests, to figure out, how should we move this? What color should this thing be? What kinds of things are people really interested in? And they create that product by adding more and more users with more and more tests until such time as they think they have something that's really good. Now notice, this takes time. They call this ship it, and they take the most amount of time of anything shipping it, because they're gradually increasing the number of people who see it and improving how it works. And those decisions are being made by this team, and every so often being reviewed by the management group, who will say, yes, that is ready to go to all of our users. And then they call tweak it. And most products spend most of their lives here, without even the management group being involved, but just that squad who owns that feature, constantly improving it, trying things out with real customers, getting feedback, and making it better and better so that their metrics, I'm sure their metrics are things like how long people spend online, how many conversions they have, until those kinds of metrics continue to, as they continue to improve. And eventually, maybe they'll spend less time on that and pick up another product. So as you can see in this environment, these guys are very involved. They're delivering real value to customers. Okay? So it's a question, are you involved in delivering real value to customers? What does it take to make sure that you're involved in that? And the next part is to see the shadow of the future. That is to make the world a better place. So again, you want to make sure that you are very good at what you do and always getting better. You want to make sure that you're involved in understanding customers and delivering something that is valuable to them and being a part of that whole conversation. And the last thing is to make sure that you do something to make the world a better place to live in. So I'm going to talk about a guy named Todd Park, who did just that. Todd Park is a Harvard Business School graduate. He did understand software, and he could actually do software, but he became a management consultant along with his friend Jeb Bush at Booz Allen Hamilton in the area of managed care, managed healthcare. And he and his friend decided as consultants what they really wanted to be was entrepreneurs. They knew so much from Harvard Graduate School about how to run a clinic. They decided they were going to start up their own clinic because they were experts. Now, how many consultants have you seen that think that they're experts and then start up their own business? And guess what happened? Well, they discovered they didn't know as much as they thought they did. In fact, their maternity clinic that they started up kind of almost died 2 or 3 times, and they realized that as smart as their education was, they didn't really understand how clinics worked. One of the biggest problems that they had was the medical records. There was no really good place. This is what the company they started, which is Athena Health. And there was really no good place to put those medical records anywhere. They finally decided to create their own web-based mechanism to maintain their clinic records while they learned how to run a clinic. And they learned how a clinic really ran, not just how they learned in school. Eventually, the clinic became successful, and they said to themselves, you know what we're really good at? We're not so good at running clinics after all. What we're good at, though, is creating good medical record software. And so they started to sell that medical record software online. It was one of the very first online record-keeping systems for small clinics in the United States. And it was actually very successful. In fact, they did, in 2007, an initial public offering, and they made tons of money. Very, very successful public offering. You know, what everybody dreams about. Well, it happened. Now, if you go to Todd Park, his wife was getting really tired of him spending 24-hour days, 7 days a week away from home. And so she said, maybe we should, go somewhere else and start a family, and you should retire and take this money that you earned and do some investment or something like that. So he did. He invested in healthcare companies. He relaxed. He moved to San Francisco, started up a family, crawling around at his feet, maybe 1 or 2 years old, and he got a telephone call. He got a telephone call from the federal government. Now, I don't know about working for the government in Poland, but in the U.S., working for the government is not really everybody's idea of what you want to do. But he got a call from the Health and Human Services Chief Technology Officer who said, and it's 2009 now, and he said, we really would like to start entrepreneurship inside the government, in Health and Human Services. And Tom Park said, no, thank you, I don't think so. And he said, well, why don't you just fly out here? And his wife was pretty upset because when he came back, he was ready to go and work for the government. Finally, after a long time, they agreed to work for the government. And by the way, it was a difficult thing because if you've ever been to San Francisco and Washington, D.C., which one would you like to live in? Well, I meant moving to Washington, D.C., which nobody wants to go to. And it also meant taking all of his investments in healthcare and putting them in some sort of a blind trust because if he, as an official of the government, he could no longer have investments. And so he did all of that because he thought he could make a difference in the government and in people's lives. Health and Human Services purpose is to improve the health, safety, and well-being of the country. And that's what he wanted to do. And so he was to bring entrepreneurial services there, and he didn't really want to go. And when he got there, however, he started looking around because now he was official and he could look at what was there. And remember, he's a data guy. He studied data for healthcare. And he saw their databases and he was just amazed at how impressive those databases were. And he said, you know what? If we could make these databases available to the public, there could be all kinds of incredible apps that could help people figure out how to get healthcare, what you do about smoking, all kinds of interesting big data information could come out if we could make this available. And so he said, what do I need to do to move this data into the general public? What he called data liberation. And he looked around for a model because he'd say, has this ever been done in the government before? And what he found is the NOAA, which is the National Oceanic and Atmospheric Administration. What NOAA does is they release all of the weather data in the U.S. to the general public. They've been doing this for 3 or 4 decades. So it's a common pattern, he said. Why not release databases from Health and Human Services to the general public? And so in 2010, about a year after he got there, he pulled together all his friends in big data and he pulled together his friends in healthcare, put them in the same room and said, what could we do with this data? And by having those two groups talk to each other, they came up with an incredibly large amount of ideas. And he said, okay, ideas don't do anything. All we want is stuff that actually works, and you got 90 days. So everybody had 90 days to come up with a starter app of something that could take the data in the Health and Human Services databases and expose it to entrepreneurs who could then start up a company with a business model using that data. So for example, here is one that happened. It's called Itriage, and it tells all kinds of different things about drug interactions, where the nearest emergency room is, all kinds of stuff that's useful. And And in 2011, 1 year later, he had not just a few of these, which happened in 2010, but by 2011, there was this great big health data initiative forum, which the Health Data Palooza. So everybody got together and showed their apps. There were perhaps 20 or 30 of them. It was very well attended. All kinds of data was now being released. And what he did was he got teams of database experts and developers from the government, and he said they were dying to have their data available to other people. And then he found a few companies out in the in the corporate world that were interested in that data, and he put the two together, and magic happened. And the people who were inside the government were allowed to expose their data after carefully making sure that all the secure stuff was removed. And they did it with these outside teams that had business ideas, telling them what data, how frequently, what format, that kind of stuff. And suddenly all kinds of apps showed up. By the next year, in 2012, there was a 2-day Health Data Palooza. This right here is a picture of what happened, of somebody that painted a picture for the Health Data Palooza. And right here, you see in the middle it says, "I missed the memo that said this was impossible." And he did. He missed the memo that said it was impossible. But by that time, he had become the CTO of the federal government. So much for Health and Human Services. Now, he started up something called, let me just summarize by saying what he did was he gave people the tools and the permission to pursue their passion. And it's this, you have a passion, you have something that you're interested in. All he did was create an environment where those, he said, very dedicated software engineers inside the government could pursue the idea that their data was valuable to the rest of the country. Once he got into the federal government, he started up something called Innovation Fellows. Innovation Fellows is a concept where any software engineer in the country that's interested in helping to make the country better will spend a year or so of their time working with government people to help make government services of some sort more useful to people. And this is spread pretty much around the country, where people who do various types of software can spend a year or something like 2 years and become part of a government organization where they're paired up with passionate government employees who want to make what they do available to the general public. Many, many innovations have come from that, but the one I want to talk to you about is an interesting thing that happened on October 1st, 2013. Now, this is a big deal in the US, not such a big deal in the rest of the world, but in the United States, October 1st, 2013 was the day that we were finally going to be able to have everybody buy affordable health care, because we don't have, health care for everybody like all the rest of the world. But now it's going to happen. It took 5 years to get to this point where a big website was going to start up with discounts for people who didn't make enough money to pay full fee. All the insurance companies would put in their plans, and people would be able to buy insurance at was considered a very affordable rate, and in fact was a very affordable rate. Now imagine, this is a big country, yes, the United States. Some states had their own, 11 states had their own websites, but every single one of them decided the day that the implementation happens, October 1st, 2013, is the day we will turn on the website. Now, how well do you suppose that worked? I mean, that's not the way you do it. But somehow or other, they missed that point in the government, and sure enough, 11 states plus the federal government turned on their website, and most of those states depended on the federal government's website on October 1st, 2013. And guess what happened? Not very much. I mean, it just could not take the rate of stuff that was going through. It's interesting that Todd Park was not involved in that, but the whole thing was, oh, you mean it had to work? They had specs. They had spent lots of time making sure that the specs were meticulously followed. Everybody did their part of the job. But when they put it all together, there was no way to get any data right through the website. It was not actually a software implementation problem quite so much as it was an operations problem, just there was a bad architecture, and it didn't support anything like the rate of data, in addition to the fact that there were massive amounts of errors. You had to traipse through 30 or 40 pages to get anything done, and sure as heck, one of those pages would have a fatal error, and off you'd go. So nobody got any health care, and nobody was going to get any health care unless something drastic happened. And now we come to Todd Park, who's right there, okay, who, remember, has the Presidential Innovation Innovation Fellows, some of them already in Washington, and he rounded up a crew of experts. Not too many, half dozen, up to a dozen at some point, of folks, for example, Google reliability engineers, people who had been in the presidential campaign and done an amazing job of get out the vote with a massive database, something that's credited with winning the election. Those kinds of people. And you can see how many, not that many folks, came and to Washington, D.C. They dropped everything and decided to move to D.C. for as long as it took. They didn't expect to get paid. They actually had to get paid because the government couldn't accept their services for free. But they took what I want to say, massive cut in pay for the time that they spent in D.C., which was less than 2 months. Because after a few days, the president wanted to know whether or not this website was totally hosed, totally disastrous, and had to be killed and started from scratch, which meant healthcare would have to wait a couple of years for the whole country, or could it be rescued? And these guys cared about having healthcare available. In fact, some of them probably had families that would be better off if they could use this healthcare website. And surely they all had relatives who would be, and friends who would be. They wanted it to work. So they went in. These are the people that really understand how to put a website up and make it work. The very first night, they discovered there wasn't so much as a dashboard, and they put one up right away. And after a couple of days, they were asked by the president, can you make it work? They said, it's a website. What, how hard can a website be, for heaven's sake? So they said, yeah, we can do it. It'll take 6 weeks. Oh, are you sure? They said, well, we're not sending somebody to the moon. We're just making a website work. This is what we do. Sure, we'll make it work in 6 weeks. And they did. They worked day and night. They had a lot of problems with the hardware. They had all kinds of, well, you can just imagine. But by the end of 6 weeks, the website was up and running and taking all kinds of applications for healthcare. And by the end of the year, or I think the deadline, which was in March, maybe 8 million people had signed up for healthcare that couldn't have gotten it otherwise. So what they said was, this was really a meaningful thing. This is what we do. We're software engineers. Making websites work is what we do. But this had special meaning because it was creating a better place in the world for people, for the people that we live with. And several people said, I loved every minute of it. I believe in the purpose, which is getting people health care, and I'm really proud of what I do. So one of the things to think about is that in your life, you're working in an area upon which almost everything else that happens is eventually going to rest. The software's the brains of everything that goes on in the world. And you understand how to make those brains work. So not just go to work and do what you're told, but go to work and deliver value and figure out how to make the world a better place. So I want to talk a little bit about the shadow of the future. First of all, and talk about economics 3.0. The new scarcity in the world is not money, okay? It used to be that it was land. If you had land, you were wealthy. And then it was money. If you have money, you are wealthy. But the scarcity today is the time and energy and brain power of bright, creative people like you. You represent the scarcity, and you represent stuff that people around the world are desperate for. So right now, economics says you are really valuable across the world, and so you have great leverage in using your intelligence to help people get value, help make the world a better place. Secondly, let's talk about motivation. So there's a whole lot of studies saying there's a few things people are motivated by. One is autonomy. So if we go to the if we go to the people who rescued the website, they pretty much had authority to do whatever they wanted. Todd Park came in, they informed the contractors, these guys are going to help you. All the managers disappeared, and the people who were left to work with them were the engineers. The engineers were really happy to see them, and they were really embarrassed by the fact that the website didn't work. So the people who came in had autonomy to run things the way they wanted for 6 weeks. And they were masters. They were really excellent. The person who led the whole charge was a reliability engineer from Google who basically did this kind of thing day and night for a living forever. And he really knew what he was doing. And they had a purpose. So when you put those three things together, autonomy, mastery, and purpose, then you can make the world a better place. And then teamwork. So what we're looking for is not completely autonomous teams, but teams that work together, semi-autonomous teams, with an internal leader who have end-to-end responsibility for delivering value as a group. And then lastly, we're looking for passion, okay? So when you do things, I propose it would be a good idea to know why. Why am I doing this? What is its purpose? Because it's hard to be passionate about a list of requirements that somebody gives you with no idea of why it's important and what it's supposed to do to deliver value. And follow your passion. And by the way, while you're at it, be great at what you do. So think for yourself, and that's the message that I have. I'm going to allow a little bit of time for should I do questions or should we switch to the next person? Thomas, what do you think? Okay, so if there is a question or two, I could take a question or two. I even have a microphone that might work. Anybody interested? There's a question right there. See if that works.
I'm not that far away. Okay, so my question would be, I realize it's not an easy question, but what's the first step for moving a delivery organization into engineering organization?
Okay. The most important step for delivery organizations is to realize that they are becoming obsolete and they're not economically good idea. So if you are trying to figure out how to start, you have people that care about the economics to convince. The first thing to do is to convince them that there is a much less expensive way to get much better results. And what? How to do that? Okay. So one of the interesting things that happened at, let me show you. I'm going to get out of here, and I'm going to show you some analysis. That I have for this afternoon. Okay. So here's a company that was doing firmware. And the very first thing they did was realize that their costs were out of control, that they couldn't add resources fast enough, that they had very long build and integration cycles, and products were lagging the competition. Now, if you're in a delivery organization, I will bet that you're probably in this position viewed from the top. And so everybody is thinking you're not doing your part. So what they did was they did an analysis of how the time of the people in the organization was being spent. Just how are we spending our time as a delivery organization? And it discovered that 10% of the time was being spent in code integration. 20% was just doing detailed planning. Now, you don't get anything for detailed planning, but that's a big waste. They were porting code a quarter of the time because they had to move code from one laser jet to the next to the next. They had current product support was taking another 25% of their time. They were doing manual testing at 15% of their time, and it left less than 5% of the time to add any kind of new features or value. So the first thing you do is something like the left side of the slide. How is your time currently being spent? How much time is being spent thrashing? How much time are teams spent waiting for somebody else to come? How much time are your bad metrics sucking up? How much of your release cycle is spent hardening, testing and fixing? It should be no time spent hardening. But I'll bet you're spending, if you have a long release cycle, maybe a third of that release cycle is spent finding and fixing bugs. That's a pure waste. So if you can start to say, here's how much time I'm spending doing stuff that I ought not to be doing, then you can move over to this side and get to the environment in which you're constantly delivering, getting feedback from customers, have a much better planning mechanism, which is taking a lot less time, and going to things like continuous integration and that sort of thing. So what happened in this organization is that the engineering manager said, we can't continue the way we're going because we have no time to do anything except just plain support. So he categorized all the lists of how much time was being spent, and he said, okay, we have to move over here, or we're going to have to close up shop because we don't have that kind of money anymore. So you need to support the fact that you are wasting an awful lot of time and money that could be much better spent in a better environment if the engineers were allowed to understand and solve the problems instead of have this cascade down stuff and just do what they're told. Make sense? You have to make a case. You have to make an economic case. And this is an interesting economic case. You have to do something like that in order to say, we don't need to be spending this time. We could be over here. And over here, when they were done 3 years later, they had 40% of their time left to do actual work. So if you could get rid of all of the junk that you're doing, you would have a whole bunch more time left to do real useful work for the employer. It cannot be bad, okay? What people are worried about is lack of control. You need to convince them that with a lot of feedback and constantly understanding what's going on, they're going to be better control than they were with the great big processes that they have today. Okay? So that's kind of how to do it. I think it's about time to say goodbye because we have more folks coming. More folks coming that give another keynote here at 10 o'clock. So thank you, everybody.